According to the National Electrical Code, specifically Chapter 334, titled Wiring Methods and Materials, Section 334.10b, Attics and Crawl Spaces, certain wiring methods are required when running electrical wires in attics and crawl spaces. The acceptable wiring methods include Type NEC cable, which stands for metal-clad cable, Type AC cable, which is armored cable, and Type MI cable, which is mineral-insulated cable. It also permits non-metallic sheath cable, specifically Type NMB, but only if it is installed in a raceway or otherwise protected from physical damage. Romex, which is a common type of NMB cable, is generally not permitted in attics or crawl spaces unless it's installed within a protective raceway or shielded to prevent physical damage. The reasoning behind this requirement is that attics and crawl spaces are often unfinished areas and can be prone to physical damage. This damage could arise from various sources, such as someone stepping on the cables, items being stored on top of them, or general wear and tear over time. NEC cable is constructed to be more robust and durable than Romex. Its metal cladding provides a significant degree of protection against physical impacts, abrasions, and other potential hazards. This inherent protection makes NEC cable a safer and more reliable choice for these vulnerable environments. Therefore, while Romex might be suitable for wiring within finished walls and living spaces where it is less exposed to physical stress, it is generally not considered acceptable for direct installation in attics or crawl spaces without additional protection. The NEC prioritizes safety and aims to prevent electrical hazards that could result from damaged wiring. By mandating the use of more robust wiring methods like NEC cable in attics and crawl spaces, the code helps to ensure the long-term reliability and safety of the electrical system. To further elaborate on the types of cables, firstly, metal-clad cable, or NEC cable, consists of one or more insulated conductors enclosed in a metallic sheath. This sheath can be either a spiral wrapped interlocking metal tape or a corrugated metal tube. The metallic sheath provides excellent mechanical protection, shielding the conductors from physical damage. NEC cable is suitable for both exposed and concealed work in dry locations, and some types are also approved for use in wet locations. NEC cable is commonly used in commercial and industrial applications, but it's also suitable for residential wiring, particularly in situations where extra protection is desired. Secondly, armored cable, or AC cable, is similar to NEC cable, but it typically has a lighter gauge metal armor. The armor is usually a spiral wound steel or aluminum strip. AC cable provides good mechanical protection and is often used in residential and light commercial wiring. However, it's not as robust as NEC cable and is generally not approved for use in wet locations. Thirdly, mineral insulated cable, or MI cable, consists of copper conductors insulated with a tightly packed mineral insulation, such as magnesium oxide, and enclosed in a seamless copper or stainless steel sheath. MI cable is extremely durable and resistant to heat, moisture, and corrosion. It's suitable for use in a wide range of applications, including high-temperature environments, hazardous locations, and underground installations. However, MI cable is more expensive and requires specialized tools and techniques for installation. The NEC provides specific guidelines for the installation of each type of cable, including requirements for supporting, securing, and terminating the cable. It's essential to follow these guidelines to ensure a safe and compliant installation. When installing electrical wiring in attics or crawl spaces, it's important to carefully consider the specific conditions and potential hazards of the environment. Factors to consider include the presence of moisture, the potential for physical damage, and the accessibility of the wiring for future maintenance or modifications. In some cases, it may be necessary to provide additional protection for the wiring, even if NEC cable is used. This could include installing the cable in a conduit or raceway, or providing physical barriers to protect the cable from impact or abrasion. It's also important to ensure that all electrical connections are properly made and protected. Use approved connectors and terminations, and be sure to tighten all connections securely. Inspect the wiring regularly for any signs of damage or deterioration, and address any issues promptly. If you're not comfortable working with electrical wiring, it's always best to hire a qualified electrician to perform the work. A licensed electrician will have the knowledge, skills, and experience to ensure that the wiring is installed safely and in compliance with all applicable codes. It is crucial to consult the latest edition of the NEC and any applicable local codes before beginning any electrical work. The NEC is updated every 3 years, and local codes may have additional requirements or restrictions. Failing to comply with these codes can result in fines, penalties, and potentially dangerous conditions. In summary, the NEC generally requires the use of MC cable or other approved wiring methods in attics and crawl spaces to provide adequate protection against physical damage. Romex is typically not permitted in these locations unless it is installed in a raceway or otherwise protected. Always consult the NEC and local codes and hire a qualified electrician if you are not comfortable performing the work yourself. By following these guidelines, you can help ensure the safety and reliability of your electrical system. Furthermore, consider the environmental factors prevalent in attics and crawl spaces. These areas often experience significant temperature fluctuations and can be exposed to moisture, dust, and pests. These conditions can degrade wiring over time, increasing the risk of electrical hazards. MC cable's robust construction offers superior resistance to these environmental stresses compared to Romex. The metal sheath acts as a barrier against moisture and pests while also providing a degree of thermal insulation. This helps to maintain the integrity of the wiring and prolong its lifespan. In addition to physical protection, MC cable also offers enhanced safety features in the event of a fault. The metal sheath provides a grounding path, which can help to quickly trip a circuit breaker or fuse in the event of a short circuit. This reduces the risk of electrical shock and fire. Romex, on the other hand, relies on a separate grounding conductor for fault protection. While this is generally effective, it may not be as reliable as the grounding path provided by MC cable's metal sheath. When selecting MC cable for attic or crawl space wiring, it's important to choose the appropriate type for the specific application. MC cable is available in a variety of sizes and configurations, with different types of insulation and sheathing materials. Consult the NEC in your local electrical supplier to determine the correct type of MC cable for your needs. Also, ensure that the MC cable is properly supported and secured to prevent it from sagging or rubbing against other objects. Use approved cable supports and fasteners, and follow the manufacturer's instructions for installation. Avoid overbending or kinking the cable, as this can damage the insulation and conductors. When terminating MC cable, use approved connectors and fittings to ensure a secure and reliable connection. Follow the manufacturer's instructions for stripping the cable and making the connections. Be sure to tighten all connections properly to prevent loose connections, which can cause overheating and electrical hazards. Regularly inspect the MC cable for any signs of damage or deterioration. Look for cracks, abrasions, or corrosion in the metal sheath, and check the insulation for signs of damage or aging. If you find any problems, repair or replace the damaged cable immediately. Remember that electrical work can be dangerous, and it's always best to err on the side of caution. If you're not comfortable working with electrical wiring, hire a qualified electrician to perform the work. They have the knowledge, skills, and experience to ensure that the wiring is installed safely and in compliance with all applicable codes. Ignoring code requirements and using inappropriate wiring methods can have serious consequences. It can lead to electrical fires, shocks, and other hazards that could endanger your life and property. Always prioritize safety and follow the NEC and local codes when working with electricity. Therefore, to re-emphasize, always consider the specific environmental conditions of attics and crawl spaces, which often include temperature fluctuations and exposure to moisture, dust, and pests. These elements can compromise wiring integrity over time. The robust construction of MC cable offers superior protection against these stressors, ensuring long-term reliability. Furthermore, MC cable provides a reliable grounding path through its metal sheath, enhancing safety in the event of a fault. This grounding mechanism helps to quickly trip circuit breakers, minimizing the risk of electrical shock and fire. When selecting MC cable, Choose the appropriate type for the specific application, considering factors such as conductor size, insulation type, and sheathing material. Proper installation techniques are also crucial. Support and secure the cable adequately to prevent sagging or rubbing, and use approved connectors for terminations. Regular inspections for damage or deterioration are essential to maintain the integrity of the wiring system. And always prioritize safety and consult with a qualified electrician if you are not comfortable performing electrical work yourself. Understanding and adhering to these principles ensures a safe and reliable electrical system in attics and crawl spaces. Let's also add some further details about the installation practices when using MC cable. Firstly, supporting and securing the cable is extremely important. The NEC specifies the maximum intervals at which MC cable must be supported and secured. These intervals vary depending on the size and type of cable, as well as the specific application. Generally, MC cable must be supported at intervals of not more than 6 feet and secured within 12 inches of every box, cabinet, or fitting. Use approved cable supports such as cable ties, straps, or staples to secure the cable to structural members. Avoid using nails or screws that could damage the cable. Secondly, bending and routing the cable needs to be done correctly. When bending MC cable, use a cable bender or a similar tool to avoid kinking or damaging the cable. The minimum bending radius for MC cable is typically 5 times the cable diameter. Avoid routing the cable through sharp edges or where it could be subject to physical damage. If necessary, use a conduit or raceway to protect the cable in vulnerable areas. Thirdly, terminating the cable. When terminating MC cable, use approved connectors and fittings that are specifically designed for MC cable. These connectors provide a secure and reliable connection between the cable and the electrical box or equipment. Follow the manufacturer's instructions for stripping the cable and making the connections. Be sure to tighten all connections properly to prevent loose connections, which can cause overheating and electrical hazards. Fourthly, grounding the cable. MC cable provides a grounding path through its metal sheath. To ensure proper grounding, connect the metal sheath to the grounding terminal in the electrical box or equipment. Use approved grounding connectors and fittings to make this connection. If the electrical box or equipment is not grounded, you may need to install a separate grounding conductor. Fifthly, inspecting the installation. After completing the installation, carefully inspect the wiring for any signs of damage or defects. Check the cable for cracks, abrasions, or corrosion, and make sure that all connections are tight and secure. Use a multimeter or other testing device to verify that the wiring is properly grounded and that there are no shorts or open circuits. Finally, documentation and labeling. Properly label all electrical panels, circuits, and equipment. This will help to identify the wiring in the future and make it easier to troubleshoot any problems. Keep a record of the wiring layout and the types of cables and connectors used. This information will be helpful for future maintenance or modifications. The NEC provides specific requirements for labeling electrical panels and circuits. Be sure to comply with these requirements. The NEC also addresses the issue of abandoned cables. If you remove or abandon any electrical wiring, be sure to remove it completely from the building. Abandoned cables can pose a fire hazard and can also interfere with future wiring installations. The NEC requires that abandoned cables be removed unless they are properly terminated and labeled.